Oh, what is up, guys? We're going to be going over the fourth worksheet today, or fourth assignment, whatever you want to call it. Now, first thing, this is all dealing with how a horizontal oscillator changes depending when you change like certain things about it. Like, what if you change the mass of the object that's oscillating? What if you change the spring constant that's pulling on the object, right? What if you change how far you stretch it? All that stuff. So first thing we need is had we been able to finish that lab when we were doing all that stuff, we would have come up with an equation that models the motion of any type of oscillating object. And that equation is on the formula sheet. So if we go to the formula sheet right here and go and take a look down here at the bottom, this is actually the equation. Let's zoom in a little bit. Right here, this is the period of a spring oscillator. So remember, capital T is for period and the S is for spring. So the period of a spring oscillator is equal to 2 pi. When you think about it, 2 pi makes sense because we always model this stuff with trig functions, and 2 pi is usually like for the cycle of a trig function. 2 pi times the square root of the mass of the object divided by the spring constant. So really there's only 3 different variables in that equation. There are period, mass, spring constant. That's it. Those are the only 3 things that affect a horizontal spring oscillator or a vertical spring oscillator, right? Any type of oscillator that is attached with a spring. Alrighty, so let's go back to the problems. So we can write that equation down because this set of problems is going to be all using that one equation, because it's basically going to be asking, if you change this, how's the period change? If you change that, and all that. So we got a block of mass M, so we can even write that on there. This is mass M. It's attached to a spring of spring constant K, and the block is pulled to the right from point B to point C and let go. So when this thing first starts, it's just oscillating back and forth between A and C. Okay. The period of oscillation is 2 seconds. So the original period is 2 seconds. All these problems are going to be changing something and asking what the new period is. So a lot of this, remember, this is what we call a proportional reasoning question. So if one thing changes, how is everything else affected? So the block is replaced with another block that has a mass of 4m, so 4 times bigger than the original mass. What's the new period? So this is a proportional reasoning question. If we go to our original equation, there's only 2 things involved in this, period and mass. So everything else is remaining constant. Because it's constant, it doesn't affect the outcome of our problem. So we want to rewrite this. You want to get rid of all the constants and rewrite this as only the stuff that is involving our problem. So the period of the spring is going to be proportional to the square root of the mass. That's all that's left when we got rid of all the constants up here. Okay. Now plug in the new stuff. It now has a mass of 4m. So I'm going to write a 4 in here. Okay. And I want to see what's going to happen when I now simplify this thing. So I have the period of a spring, right? This radical 4 in here, the square root of 4 is 2, so a 2 comes out front. Still can't really do anything to that. So this whole side of the proportionality got doubled. And because they're proportional, whenever one thing over here doubles, over here also has to double. Okay, so when you quadruple the mass, what ends up happening is you're going to end up doubling the period right there. Okay, so the old period was 2 seconds. So the new period, so the period doubles, which means that we have a new period of 4 seconds. Okay. Same exact process for the next one. A block of mass 4m is removed, replaced with the original one. So in other words, we're back to the original setup. This time, the spring is replaced with a spring that is 4 times stronger, so 4K. What's the new period of oscillation? So get rid of all the constants, right? We only have period and spring constant changing. Everything else can go away. All right, so what do we have left? We have that the period is proportional to the square root of 1 over k. That mass disappeared, so it's just left with a little placeholder 1. All right, now plug in the stuff that we know. We know this 4 down here in front of the k. It's 4 times stronger spring constant. So when we simplify this, we end up with the square root of 1/4 is 1/2. And then we're left with the same 1 over k. Okay, so if that 1/2 got in front, just like before, the 1/2 has to go out in front over here. So it is now technically half of whatever the original period was. And so let's write that, half of the original period. So that tells me if the original period was 2 seconds, new one is going to be 1 single second. All right. Number 3, the block is now a mass m and has spring constant k, so it's back to normal. Okay, the block is pulled 2 times as far away from the equilibrium position and released. What's the new period? Well, when I take a look at this equation, there's only 3 things involved that can change in this. Period, and we're not changing that. We're trying to see how it is affected. Mass and spring constant. Where the thing is stretched has no effect on our period. Okay, so period is the same because the stretch length has 0 effect on the period of the thing, right? If you pull it further away, there's going to be a greater force on it. It's going to make it go back quicker. It's going to always oscillate in the same period. All right? And for the last one, we're going to have multiple things changing. So now we're back to the original setup, but for this trial, the mass of the block is 1/2 of the original mass, and the spring constant is going to double, and we want to figure out what the new period is. So take a look at the equation, get rid of all the constants. Okay, now the mass is changing and the spring constant is changing, so just 2 pi goes away, and we're left with the period is proportional to the square root of m over k. All right, and we just plug in the stuff that we know. We know the mass got halved and k got doubled. So it's 1/2 over 2. Okay, when you simplify this, 1/2 over 2 turns into m over 4k, right? So just continuing on over here, period, the square root of 1/4 is 1/2. And because we got a 1/2 in front of this side over here, then now we got to have a 1/2 in front of the other side. So it is half of whatever the original period was. And if, since the original period was 2, that tells me that the new period is 1 second. All right. So as you can see, the process for all the proportional reasoning stuff is pretty similar. You kind of go through the same steps, get rid of the constants, plug in whatever thing is changing, and see how the other variables affected. All right. So I will see you guys later. Text, email, questions, whatever like that, and adios.